Fourth question. It's a calculation. Copper reacts with concentrated nitric acid to form cupric nitrate, nitrogen dioxide and water. So first, before doing the calculation, we need to write the balanced chemical equation for this reaction. Copper reacts with concentrated nitric acid to form cupric nitrate, nitrogen dioxide and water. Copper converts to cupric ions. We can balance that half reaction like that. Then nitrate ion, it reduces to nitrogen dioxide. The oxidation number of nitrogen atom in the nitrate ion is +5. You should be able to do that calculation. Then what about the oxidation number of nitrogen atom in nitrogen dioxide? It is +4. Oxidation number of nitrogen atom has reduced from +5 to +4. There is one nitrogen atom in the reactant side, there is one nitrogen atom in the product side. So number of atoms are balanced. Then +5 to +4, which means one electron has gained by the nitrogen atom. Then we can consider about the overall charge. In the reactant side, it is -2. In the product side, overall charge is 0. So we can add 2 hydrogen ions to product side. To the reactant side. Why did we add hydrogen ions? Because nitric acid is there. So it releases hydrogen ions. Then there are 2 hydrogen atoms. We can add 1 water molecule to balance the number of hydrogen atoms. 3 oxygen atoms. So the half reaction is balanced. Now we can add these 2 reactions, but before that we need to multiply second equation by 2. 1 copper atom, 4 hydrogen ions, 2 nitrate ions, 2 electrons, 1 cupric ion, 2 electrons, 2 nitrogen dioxide molecules, 2 water molecules. 2 electrons, cancelled out. Then 1 copper atom, 4 hydrogen ions are there. To get 4 hydrogen ions, we need 4 nitric acid molecules. Then what will happen? We will get 4 nitrate ions, but we need 2 nitrate ions. So there are 2 nitrate ions excess in the reactant side. Product is cupric nitrate. We need 1 cupric ion. So there should be 1 cupric nitrate. So there will be 2 nitrate ions excess in the product side. Then 2 nitrogen dioxide molecules, 2 water molecules. It's clear that there are 2 nitrate ions excess in both sides, so they cancel out. So this is the balanced chemical equation for the reaction. So we can write that before doing the calculation. Now we can move to the calculation. The mass of copper is given. So we can calculate number of moles of copper. used for the reaction. When the mass is given, we can use number of moles is equal to mass over molar mass formula. Mass is 12.7 grams. Molar mass of copper is 63.5 grams per mole. Grams cancel out. We can move one decimal place to right, then it is 127 over 635. Then there are no 635s in 127, 0. Then decimal place we can add a 0. Then there are two 635s in 1270. So 0.2 moles of copper has used for this reaction. Then the other reactant, it is nitric acid. 300 cubic centimeters of nitric acid were used. So we can calculate number of moles using the formula. Concentration is number of moles over volume of the solution. We can multiply both sides by the volume. Then we can calculate number of moles. It is equal to concentration times volume of the solution. Number of moles of nitric acid used for the reaction. Concentration is 2 moles per cubic decimeter. Volume of the solution was 300 cubic centimeters. It is 0.3 in cubic decimeters. So it is 0.6 moles. Okay. After that, can you deduce what is the limiting reagent? It's clear. If you have 1 mole of copper, we need 4 moles of nitric acid. So when we have 0.2 moles of copper, we need 0.8 moles. 4 times 0.2 moles. It is 0.8 moles of nitric acid. But we have used 0.6 moles of nitric acid. That means nitric acid is the limiting reagent. So it is clear that limiting reagent is nitric acid. The limiting reagent and the volume of nitrogen dioxide gas produced at standard temperature and pressure respectively are. So we need to calculate the volume of the nitrogen dioxide that is produced by this reaction. So next we can calculate number of moles of nitric acid produced. So limiting reagent is nitric acid. So the mole ratio between nitric acid and nitrogen dioxide is 4 to 2. That means 2 to 1. Then number of moles of nitrogen dioxide produced is half of this. That means 0.3 moles. Then how to calculate the volume of nitrogen dioxide at standard temperature and pressure? What is the formula? It is number of moles is volume over molar volume. We can multiply both sides by molar volume. Then we can calculate volume of the nitrogen dioxide gas. Volume of the nitrogen dioxide produced. Number of moles times the molar volume. It is given 22.4 liters per mole. 3 times 4, 12, 1, 3 times 2, 6, plus 1, 7, 3 times 2, 6, 1, 2 decimal places. So the volume of the produced nitrogen dioxide is 6.72 liters at standard temperature and pressure. So it is clear that the fifth answer is the correct one. It stated that the limiting reagent is nitric acid and produced volume of the nitrogen dioxide is 6.72 liters. The correct answer is fifth one. Please check your rough sheet and identify where is the error and correct those errors. When you write an answer for an MCQ question, do you need to write statements like this? Actually, no. But when you try to understand how to write an answer, you need to write the answers like this, step by step with statements. When you write answers like this, you understand the concepts and how to write answers. Then during the exam, you can roughly do these calculations and get the answer within allocated time. Want to score high in your term test and aim for that A+ in your advanced level exam? Join our smart paper discussion class today. Scan the QR code or click the link in the description to get started. Stay curious, stay focused. See you in the class.